Hi guys, in this video I'm going to show you how to find a perpendicular distance of a point from a point to a plane using vector. So in the previous video I have already explained about how to find a perpendicular distance from a point to a line. So here I'm going to discuss about a perpendicular distance from a point to a plane. So here they have given the coordinates of the point we need to find out, point 0, 0, 0, which simply means it's the center, O, which simply means O. And the plane's equation they have given us 3x minus y plus z minus 4. So here the question is, how are we going to find the distance, the perpendicular distance from that point to this plane? So if you are new to this expert tutor, please take a minute to subscribe this. Also, if you like to watch any other previous videos regarding vectors as well as matrices, I have given the link in the description so you can always watch them. Let's go to the question without any further delays. Okay, if you are new to this question or if you like to try it in your own, please pause this video. After that, try it in your own. At the end, watch the rest of the video and compare your answer with this one. So here in the previous video also I have mentioned, if you are having a question from a vector, you need to draw a simple sketch, otherwise it would be a little bit difficult to figure it out what's happening over here. So here I am going to draw a point, and as they have mentioned, we need to draw a plane over here. So let's say this is a plane. So think like it's in the 3D, which simply means there is a 3D plane over here in this. It's outside and inside the paper, not on the paper direction. So over here, I have marked the point over here, and the coordinates of this point is 0, 0, 0, and I can directly mark the equation of this plane over here, 3x minus y plus z minus 4. The question over here is equal to 0. The question over here is we need to find this length, perpendicular length. So they have asked the perpendicular length, so we can predict it's going to be 90 degrees. So we need to find this length using these two data. So how are we going to find this? The first thing is, as I have already mentioned in my previous video, when you are finding any angle or any distance, first of all we need to find any angles related to this, or we need to find what's the length of this, what's the direction vector of this. Otherwise it would be a little bit difficult to carry out this question. So here first of all we need to know any points over here in this plane. How can we get any points over here? We can directly substitute any values for x and y as well as z and get the point from this. We can, please note this, we can get the points in this plane by substituting any number values for these x, y and z, and also it should satisfy this equation. So that's the main thing. So also the main thing is we can directly substitute any values, but the condition is it need to be satisfied by this equation. So here for the easiness, I'm going to take an x is equal to 0 and y is equal to 0. You can also take a point like this, but they have given the point 0, 0, 0. So it's your wish, you can take like that, not a problem at all. But here I'm going to take like x is equal to 1, y is equal to 1 to make a difference, but you can always use 0 and 0. If you make these two zeros, that would be automatically get the value of 4. So I'm going to take these 2 as 1. So if I substitute over here, 3 minus 1 is equals to 2 is equals to minus 2, and that is going to be. So now I got a value for for a point, but I actually don't know where's that point, so I'm going to mark it like this. So now I'm going to mark the point over here. It's going to be 1, 1, 2. So the next question, from this point we can find the direction vector of this one. So this is similar. From this step, it's going to be similar to the previous question, which asked about find the perpendicular distance from a point to a line. From a point to a line, it's going to be the similar steps from this point. So in the previous video, we have found the value of this length using these 2 points. Likewise, we can also find the points, the length of this side. The next thing is we need to find what's the direction vector of this. How to find that? What's the direction vector of this which is perpendicular to this plane? Note this, it would be very useful for your exams. If you have a plane's equation, the perpendicular line from this plane would be having the direction equation of 3 minus 1 1, which simply you can get by substituting the coefficient of x, y and z, 3 minus 1 and 1. If you get this, it would be the perpendicular direction vector for this plane. So note that this is the main point. If you knew that, you can directly solve this, because now we knew the value of this direction vector. Also, we knew the value of this. We can directly find that. If I going to find this length, I can directly tell 1 minus 0 and whole thing squared would be 1 squared, plus if I do that for these two squared, I'll be getting root 6. So now I have found the value for this length. So after that, we need to find this length. But the thing over here is you can use a simple dot product method. But before that, I'm going to tell how are we going to do that. So we need to do the dot product for this vector and this vector. But the thing over here is actually we don't know what's the unique vector of this. There are many other ways to do that, but here I'm going to tell the unique vector method, but it's not the only method, so you need to know any other method too. So these are the simple steps. You can directly find the direction vector of this by using these 2 points. You will be getting 1 1 and 2. So this is going to be the direction vector from this side. So in this side it's going to be, in this side it's going to be 1 1 2. If I use these 2 points, if I'm going to find the direction vector from this point, I should deduct these 3 coordinates from these coordinates. So I'll be getting 1 1 2. And the thing over here is the direction vector from this plane, the normal vector, which simply means the perpendicular vector for this plane, is towards this side. So we need to take the negative sign over here to pull this in this downward direction. So I'm going to take the minus value of this. So we can directly tell minus 3 plus 1 minus 1 over this side towards downside. And we already knew the value of 1 1 2. There are many other ways too, but I'm going to tell 2 simple ways, but you can use any ways. So if you use the dot product between these two, you will be getting the answer for this angle cos theta. From this, you can directly find this, take it like AB cos theta would be equal for that. Actually, it would be the 90 degree. Okay. However, the thing over here is this is one method. The actual thing is we need to find use these direction vectors and find this angle. After that, we can substitute AB cos theta. And another method is when you are finding this one, you can directly use an equation called AB, which means this direction vector AB into n vector. So it's going to be minus, because in the next iteration, so this side, and I'm going to multiply having the dot product from this side AB vector dot minus n vector. If I do this and take the mode value, it will show the answer for this. So here I have mentioned not only the n, which means the normal vector, I'm marking a this sign over here, see a sign over that n. What's mean by that is it simply means the unit vector of this direction vector. If I'm finding the unit vector of this minus n, it's going to be, I need to find the square of these three numbers and find the root. So if I do so, 3, 3, 9, 1, 1 is going to be 11, and I'm having minus 3 plus minus 1. So remember that this is known as unit vector in the for the n vector, and this is the minus sign to use this sign. So here we knew the unit vector for this direction, and if I use this AB into minus n, I will be getting the direct answer for this distance d. If you're not sure about this, you can directly use this. If you find that, you will be getting an answer. Let's use this and try to explain it a little bit further. So how are we getting this d directly? The thing over here is, if you use ab into minus n, you will be getting mod of ab, which simply means mod of ab, the value of this length of this ab, into mod of n. And this is a unit vector. As this is a unit vector in the n direction, it's going to be 1. So AB into 1, as I'm going to use this unit vectors, that's why it's going to be 1 over here, into the angle between this n direction and this AB is going to be theta. If I lay like this, theta is going to be cos theta, as this is a dot product. So it will give an answer of AB cos theta, which gives the same idea. However, it would be easy if you memorize this, otherwise it's not a problem. You can find the direction angle between these two by using the dot product. After that, you can simplify in this root 6 the length of this AB. After that, you can use the trigonometric functions to find this. So I hope this video would be clear. If you have any doubts, please comment it below. I could solve that too. Thank you for watching.